All right, we have 7.2 or section 9.2 in the old version of question 19, which has a plane that's going to this point right here, but there's a wind blowing from the southeast, and so the plane actually needs to follow this route here so that the wind will blow them to the point where they want to be. So this wind I didn't put is 25 miles per hour, and the plane would normally have been going 96 miles per hour so that they could do the distance of 192 miles in 2 hours. So with the wind, we want to follow this route, although I think we're going to have to adjust the 2 hours is actually going to be a little bit, we're going to have to think about that when we do get there. I don't know, maybe this is in our section involving these vectors. So we probably are supposed to do this using one of the things we learned about adding vectors. Is that what we need to do, is do the adding vectors method instead of the like law of cosines, even though I prefer law of cosines? I don't know. I'm inclined to think, because I know the vector method took forever, that I want to go ahead and do law of cosines anyway, and then we're going to think about how to make it be in 2 hours. Okay. So we need the square root of 96 squared plus 25 squared minus 2 times 96 times 25 times the cosine of 53.2. Let's calculate that. You guys can double check my work. So 96 squared plus 25 squared minus 2 times 96 times 25 times the cosine of 53.2. Square root that answer, and I get 83.46. I don't think we have to make any adjustments. We're just finding this, right? The plane is what's going to get us there at the right time. That's because we're just adding these vectors together. Or we're taking this vector and subtracting this one is what we're doing. So we're taking what the plane, where the plane would have gone, and we're subtracting the vector of what the wind would do to find out what the plane needs to do to be here. So all we're doing is, yeah, that should be our answer. Anyone have an answer key to check if that's the right speed so that we know we're on the right track here? So then this angle, awesome, cool. Yeah, I'm about to do, I was about to do that, but go ahead and tell me what it is and then we won't have to check it again later. So north 3.1? Okay, sorry, I didn't hear. 22.1 degrees east. Okay. Okay, so let's go ahead and find theta, which would be this angle in here. So to do that, I'm going to use law of sines because I prefer that. So let's do sine of theta over 25 miles per hour is equal to sine of 53.2 over 83.46 miles per hour. So cross multiply, so we do the inverse sine of 25 times the sine of 53.2. I'm totally guessing they want us to practice this with the vectors method. I'm sorry, I'm probably showing you the wrong way to do this. I just prefer this. We can do it the other way if we want, but I think we should get through the notes first, and then we can come back to it and do it the vector way. Okay, so then that would divide by 83.46. Put that in our calculator. So inverse sine of 25 times the sine of 53.2 divided by 83.46. Close those parentheses. And I got 13.88. So that would be this angle in here. So we would add that to the original angle 8.2. So 13.88 plus 8.2 is 22.08, or that would round to 22.1 degrees. So there's our answer. North 22.1 degrees to the east. So they make us all confused by, instead of figuring out where the plane would actually go with the wind, figuring out where the plane needs to go with the wind so that they end up where they want to be, which actually makes a lot more sense to actual practicality, right? That's what's actually what we would want to know. All right.